And now let's learn more about drilling. Emily, are you with us? Or Gil, are you with us?
Sorry, just trying to unmute. Hi, how is everyone doing today? Hope you had a nice lunch. So today we're going to speak a little bit about the new forms that we're going to do for everything from our side of the drilling project, which is from the perspective and geophysical. The perspective we decide that we take the project, and then it turns into a geophysical survey. And from there, we go to drilling, design, installation, and development, the pumping test, and all things like this. So here we are. We're gonna, actually Gil is gonna help me. He's going to help us run through the forms, and we're gonna go through all of the forms. And now we will be needing different forms because up until now, we were working with the installation form. And the variation in the information that we were getting on the installation form was from kind of like very minimum 0 to people writing whole books about what was happening in the entire process. So we want to use these forms hopefully to more streamline what is necessary in our reporting process, and also to make it a little bit easier so we don't have to add too many things. We just need to get what the basics are. And then that will hopefully help us move forward in choosing the right projects and the right locations, and also being able to much more easily manage the projects that we're working on and have more successful projects so we don't have to go back to and do more maintenance on. So we have a fake project here that we're going to go through in the Innovation Africa app. If you guys want to open this up and do it with us as well, please feel free to. I don't know if it's possible to go into the app if they're not in Uganda. Either way, yeah, we'll go through it. You guys might not have access to this app, so we'll go through it. But these are the new apps, and you can actually go into any country, into the country that you're working on, and you could press in process, pick a project, and then you can go through, depends on what country you're in, but you can go through and see these new forms in real time while we're going through it ourselves. Okay, so let's get started. So after we have had a prospective form be approved, then we go through the contracts with the contractor. They say, great, okay, we'll do this project for you. And then they go through a geophysical survey. Start new form. And the survey stands outside of the drilling forms currently, because when we do a survey, we could do a survey for multiple boreholes, but for the one borehole you work on, that needs to be separate. So the survey here, we go through, we have the name of the person who is supervising the survey.
You'll have a drop down.
You'll have a drop down list of all the people that are in that are available, even if it's not just a hydrogeologist. Whoever is doing the supervision for the survey can write their name there. Then we want to have the full name of the surveyor. And this is comes out of experiences that we had where we didn't know who the actual person was who was doing the survey. And so we want to make sure that we have the name of the person who was in the field doing the survey, whoever was in charge of the survey. And then also we have a space for adding a survey contractor. So if it was the contractor that's actually doing the drilling, or someone who was independent. And then we also have here the method of survey. In the method of survey, we have a few options that you can choose, and you can choose multiple options. It doesn't have to be just one, because hopefully these surveyors are using multiple options to combine together to get a better result. So on the bottom here, we have survey completed, yes or no. And what's special about this?
If yes, then we have the date.
Yeah, okay, if yes, then we have the date. And if no, then you can't move forward. Okay. So yes, if the survey is completed, you give it a day, like today. And then what's important about these forms is that we have a space to add GPS coordinates for each one of the points that were surveyed. This is different from before, because we used to only have, until we got the survey report back, which can sometimes take days, we only had information about where the actual prospective water source was in the village. And now we have all the areas that were surveyed. And so this can help us out just to find out where elevations are in Google Earth, and it can help also the engineers looking forward to see whether or not one point is more viable than another, just based on location. So if you want to take a GPS, you have to click on this button, and you take the coordinates. It gives us the coordinates of where we are right now. And for this one, it doesn't give us an altitude, but I think it's because we're looking at it on the computer and not on a phone. Then we want, for every one of these perspectives, we need at least 3 perspectives and at least 6 points that are surveyed. We also have underneath every perspective, we have this question that's potential threats of contamination in the surroundings. And this is just meant, I mean, it's just a simple yes or no. It's meant to make anyone who's doing this survey stop for a moment and say, wait, is there a threat around here? Is there not a threat around here? Let's double check and make sure that there are no latrines in the areas. We're not right on top of a stream or next to a dried stream, things like that, that we want to make sure that we're avoiding those situations. So,
And if they do, then
if you do have a place where there is a threat of contamination, then you can write yes and explain. And then in the future, you can decide whether or not that is something that we can, we can treat that issue, we can move a latrine, we could do stuff like that. But it's good to have an explanation of where you see these threats and what kind of threat it is. Then we go on, and there's 2 more spots for more coordinates for the second and 3 more spots for the second, third priority, and then the 4th priority. 3 are is the minimum. And then from here, we also have the photos of the survey that we can add as well. And we have the options. Oh, we also have, and that gives us, that's where we need to have at least 6. So we want to have 3 priorities, and we want to have at least 6 points surveyed, because oftentimes we're finding that they only go through and they will only survey 3 points. So they haven't surveyed more than 3 points and chosen what are the good points out of those 3, out of multiple points. Sometimes they just go and take 3 points. They are finished with the survey in half an hour, 2 hours, and we don't really have a good idea of where there would be water, as we would if we did a wider survey to get more of an idea about where the priorities should be. So here you can add photos of the survey. We'll go through, if we have time at the end, a few example pictures. But again, I see that this is really not an issue on the installation forms very much. We see a lot of pictures of the surveys. And then with the picture, you can add some comments explaining what the survey is. Especially you want to get like a picture of the setup when they have the different pegs and things like that. You want to have a picture of what the setup looks like, and have pictures of people taking the survey. You can limit it to like 5. We don't need too many more than like 5 pictures is plenty. Okay, moving on. We would
have submitted it.
Okay, so then you want to either save if you have to come back to it or submit it. And we want this to happen on the day of. So while you're out in the field, while you're supervising, just save it if you don't have service, but submit that day, because we really want to have the information on that day so we can kind of we cannot slow down. We can stop slowing down the process by waiting for reports from contractors, and we can just keep working. Okay, so now it's really important. We're going to start a borehole supervision form. Now the borehole supervision form has multiple stages, and we need to have a new form for every borehole. So that means that if we have multiple boreholes in the same village, each borehole has its own borehole supervision form. This is because even if a borehole is dry, you still want to have a form, because that gives us just as much information as a wet borehole does. If we have a successful borehole, that's amazing and we can go forward with it. But if we have a dry borehole, we also want to say, okay, yeah, we had a dry borehole in this place, and we can use the fact that that borehole was dry and put it with a survey as a potential and use that as data for where we move on from there. So the first stage is drilling. We've taken the priority site from the geophysical survey, the first priority site, and we want to say who is doing the drilling supervision. Most of the time, it should be the IA team, the hydrogeologists, but sometimes when we are really overloaded, we can sometimes have a contractor come and do the supervision as well.
And depending on what we select, we'll have a different drop down. So if we select the contractor, then we can see here the list of the contractors. But if we chose the team, then we would have the same drop down as before with all the specific countries team. So let's go with team because that's what we prefer.
And then from there, we go on and we say which priority it was. So from the geophysical survey, we pick a priority. Normally we'll start with the first priority because the surveyor decides that, and we approve that or change priorities if we decide that the data is better on a different priority. And then at that first priority, we also want to take a GPS coordinate to make sure that we know that these two locations are the same. And also it gives us a better idea, because sometimes you have to move the location of the actual drilling because the drill rig can't get there, or there's something that happens where there's a lot of, there's too many rocks, something like that. You want to make sure that we have both the data from the GPS from the survey and also the real-time data of where we're doing the GPS, where we're doing the actual drill. Then we have the drilling start date. Usually drilling shouldn't last more than a couple of days, but sometimes if you get the equipment stuck in the hole and you have to come out, or other things like that, you have a drilling start date and a drilling end date. So that's really important to write. And then we have the drilling depth, and that's the drill depth, and that's the total amount, total depth that the borehole was drilled in the process. And we make sure that we have the borehole diameter, and this is the main borehole diameter that's to depth. You can choose the unit, which is either millimeters or inches, depending on what country you're in. I understand that some places it's more common for inches, some places it's more common for metric. And then for here, please remember that our minimum for getting to the drill depth is 150 millimeters or 8 inches. Or wait, 210 millimeters or 8 inches, and that's the drilling diameter itself. The casing itself is 150 millimeters or 6 inches. Okay, so the more information that we go to when we're drilling is that we want to have the first water strike depth, if there is one, and we want to have the first water strike yield. So this is something that we should be careful of, because we want to make sure that we're logging and recording how much yield we have coming out as we're drilling down, so we can check the water strike. So either you have to do it by using a bucket and a timer, or by using a V-notch and noticing where there are fluctuations in the flow. So here we asked for 2 of the most important pieces of information. We know that sometimes there can be more than 1 water strike and 3 or 4 water strikes even. So what we've taken it down to here is where the first water strike was and where the main water strike was. And then we ask for the yields of those 2. So it's a cumulative water strike. If you're at a shallower depth, you say, go up to the other. So we also, when we ask for the first water strike yield and the main water strike yield, we want you to measure it at the first water strike yield, and that's what the yield is there. And then at the main water strike yield, as you're adding it up, you can figure out what the main water strike yield is by subtracting the previous strikes or the other strikes. And then at the bottom, when we get to the drill depth and we're stopping drilling, we want to have the full driller's yield at that depth, which is at the total depth. And then we ask the question if it fulfills the minimum yield requirement of 1 liter per second, yes or no. And then after that, we have places for pictures for the drilling process, and we will show examples later, but we want pictures of the borehole, the drill rig, lithological samples. You can also take pictures of the penetration rate log and the lithology log. So there's 2 sections here. The first section is more about like what you have in the field, what the rig looks like. And then the second section is the area where it's really, really important for us, because we're having situations where we're not getting all of the data we need for each borehole. When you're in the field and they're taking field logs, sheets, we want to have a picture of that. So here we also have 2 spaces, one for the penetration rate log, and then the second for the lithology log. And so when we take a picture of this data, you just take a picture of whatever log the contractor has taken. That's amazing, because then we don't have to wait 2 weeks to find out what the report says and double check. It's a place where we can kind of catch any mistakes that were made and make sure that we have all of the data for that borehole.
Should I just show them anyway? Should I do the presentation?
Sure, we can.
Okay.
So we're going to go over to some examples.
Yes, please. That's a good idea. Thank you.
Yeah, but it's going to be sharing here. hold on, I got it. Okay.
Okay.
So for the geophysical survey itself, this is we did, oh, okay.
Yeah.
Oh yeah, we didn't add it. Okay, next one. Then we have the borehole supervision. So here are the pictures we're looking for. In the drilling section, we have, this is a picture of, on the furthest to the left, we have a picture of the water strike being taken. Here we have a V notch. So you can measure what the water strike is based on how high the water is flowing out of the V notch. And that's a really good indication of whether or not we're getting a higher yield as we go deeper down. And also if we have a lower yield, if we're losing water. Second picture is in the middle is the drill rig. And then a third picture is an example of the lithological samples that are taken. We would prefer that in this picture, you take all of the lithological samples so we can go back to it as a record for later. So this would probably be completely filled up, or the samples will be arranged on the ground. But it's just so we can go back to it and kind of see the variation in the lithological samples as we go. Here we have two examples of field forms. We have on the left, the penetration rate log. And on the right, we have an example of the lithology log that's in use. And so these don't need to be on a computer. They just need to be whatever you did in the field. And we want to have that data, because once you take that home and copy it and double check it and do all this stuff, it leaves a lot of room for human error. And we want to make sure we have whatever happened in the field that day for sure. So that's what we want to have. And then let's go, we're going to go back out to the form itself.
Mm-hmm.
Okay,
Good.
so from here, those are the pictures that we were looking at. And then also here we have this, okay.
It's
Yeah.
just
Yeah. Okay, then we have this, we want to take a measurement of the static water level. Usually that's on the second morning. If you haven't finished drilling in that area, or you did finish drilling, that'll be the morning after, because you want to give the borehole time to recover. And then after that, we have a question of whether or not the borehole is dry or successful. It's always successful, never dry. And then we want to ask if the supervisor, whoever is doing the supervision, would recommend to proceed to the next stage. And if not, we would love an explanation. So this will kind of help us do a little bit better work of what boreholes were good, what boreholes were bad. And it will help us keep track really of, especially in places where we have to drill multiple boreholes. It'll help us really keep track of what we're doing.
Okay. Now we can talk about when we submit this form, it generates the an ID. So we'll see it in a sec.
So this is what we were talking about before, where we want to make sure that every borehole has an ID number, and that once you start that ID number and we do have a successful borehole, then we're going to continue on with that borehole itself. You don't want to go back in, start a new borehole and do a different stage. So you want to stick, once you've started a borehole, you stick with that ID for that location. And you can also double check it based on the coordinates you remember from the survey. Okay.
Next.
So we're going to be doing the well construction for this. And these should happen like 2 days difference between each other. So you shouldn't have too much confusion. So in well construction, again, we have whoever is doing the supervisor. And then we have the casing diameter unit, and also the size, again, 150 millimeters or 6 inches. And then we also have the casing material type, because in most countries we do PVC, and in South Africa we do steel casing. So we want to make sure that it was done like that. And then if it's PVC, we want to make sure that the casing is threaded and that they screw into each other, with the steel casing that's welded together. So that would be the difference. We ask whether or not it meets the requirements. And then we ask for a picture of the casing. This is in order to ensure that the casing is in new condition, it's not broken. And it's something that when you get to site, you should be double checking and making sure that all of the materials are up to IA standards, that the casing is good, that the gravel pack is clean, well sorted. All the things that are going into our boreholes need to be in tip-top shape. And so we have pictures for each of these things, just take a quick snapshot. And then also we want to double check that we have the bentonite for the sanitary seal. And we have the type of bentonite as well, which is either using pellets or powder. And take a picture of that. And then we ask here if the borehole is cased to the total depth. Again, this is one of the differences that we mainly hit with South Africa, where if you have a steel casing, you usually only do the steel casing up until the 20 meters or until they hit they finish going through the overburden. And then we give the maximum depth of the casing installation. So that's if it's the whole borehole, then the whole borehole depth, or if it's a partially cased borehole like in South Africa, then it would be up to 20 or 30 meters. Then we have the total length of plain casing and the total length of slotted casing. This is mainly to make sure that we have an agreement between the borehole design and the form itself, because a lot of times we'll get sent a borehole design and there won't be numbers on it, or the numbers will be kind of messed up. So we wanted just to have a double check there.
And also the screen.
And then we also have the size of the slotted screen, whether it's 1 millimeters, 2 millimeters. Remember that our minimum is 1 millimeter. And then we have the depth of the bentonite seal. Remember, we don't want to allow any water strikes in underneath 20 meters. We want to make sure that all of that overburden water that's directly from the surface that could be contaminated and will most likely vary with season is not coming into our boreholes. And then we want to give a depth from depth to depth in that section. And then we also want to talk about the duration of borehole development, make sure that the water clears and is a minimum of 1 hour. So we can move on from there. And then here again, we want to have our record from the field, and that will be in the well-designed sketch. And then the photo of the borehole construction log. So the well-designed sketch is what we plan before we do the installation. And the borehole construction log is something that the contractors will do themselves. Both of these things should be done by the contractor and they should be approved by the supervisor. But a lot of times we have to help them in this process. So then we have the question, if the supervisor is recommending to proceed to the next stage, we want to make sure that you guys also have ownership over this process and you are saying, yes, I think that this will be good. I believe that there's no reason that this borehole shouldn't be a successful borehole. Nothing weird happened. It wasn't a problem with installation or something like that. So again, we give a place to explain and to recommend whether or not we should keep going with this project. And again, we have spots for comments and then these pictures here. That's it.
Move back to here.
We'll show some, no, 7.
Yeah.
Okay. So then we just did the well construction form, and then we have here pictures of casing, and you can see on the casing on the left that there's really good indication of the threaded casings, making sure that they screw into each other and then they're not glued together, because oftentimes when they're glued together, they fall apart and then we have to go back and fix it. Then here's a really good example of nice gravel pack that's all the same size. And then we have another picture of pellet bentonite. As well, on the left here, we have the well-designed sketch, which is the initial plan for how they're going to do the installation. And then on the right, we have the field logs that we got from the contractor. That was what was actually installed. So a lot of time there's kind of a back and forth that happens with the well-designed sketch. Sometimes we ask to add something else, something little, but you also want to make sure in both of these cases that you have all of the numbers that are involved. So if we have a picture, but there's no numbers, it doesn't mean anything. We can't use it to approve or disapprove or use it going forward. And so we want to make sure that all the numbers are there, that there's a lithological log as well. And then hopefully we get some, and not hopefully, we also must have an indication of where the water strikes are as well. Okay, so we're going to submit or save and go to the next stage.
Sorry, I didn't actually need to do that.
It's okay.
Okay, so now we're at pumping test.
Yes. So at the pumping test stage, we again go do the same thing. We want to have who the IA supervisor is, and then we also want to have the name of the pumping test contractor because oftentimes they're subcontracted. So we also are asking for a few pieces of information here about the different things that are set up. So we want to make sure that we have the height of casing above ground level. This is important because when you're doing the pumping test and you have the sensor inside, oftentimes we say meters below ground level, but the casing is higher up. So we want to know what height that casing is at in order for us to be able to do the correction. Because when you're measuring what the depth is from the sensor, you're measuring at the top of the casing. It's kind of like
this is for measuring water
for the
level.
pumping test. For measuring the water level for the pumping test, if you have a casing and you have a sensor down in the bottom, you're not going to hold the measuring tape on the top and then imagine what it would be like at ground level. You're going to measure at the top of the casing and then subtract whatever the height of the casing is from the side. So that's usually how we do it. We want to make sure that we have that height on there so we can do the correction. Then the first thing.
I think yesterday you showed us, so 2 days ago, you showed us a picture about it, explaining that if you can find it again, but if not, it's okay.
I don't think we have it on hand, but basically, yeah, it's basically just some of the casing that sticks above the ground. And when we're, like Emily said, when you measure the water level, I don't know if you want to try to demonstrate it here with something.
Okay, this is cracked. Okay, so say this is the ground level and this is the top of our casing, right? So I have a seret, a tape that can measure what the depth is. It's just like a tape that you'd use if you're sewing. And you basically say, we want to take the measurement from ground level, but I don't want to think about how deep it is over here. I just want to take the measurement from the top of the casing and then subtract whatever the ground level was. So it's easier to measure where it's from, and that can keep everything uniform and make sure that everyone is measuring on the same depth. And that's for when we measure, because the pumping test, we're always going to be measuring what the level of the water is, what the drawdown is as we're pumping. So the first thing we do is we measure the static water level, what the water level is with no pumping happening. Then,
and this is important that we put the units here, MBGL, meters below ground level. So while here we do want to know what the height of the casing is, we also, we do ask that the static water level be measured in meters below ground level. And since you give the information of the height of casing above ground level, then we can always do the subtraction ourselves. But in theory, we expect you to do the subtraction.
Yeah. Okay. So the next thing we need to identify here is what the pump depth is, and that's decided based on the well design. In the well design, we're making sure that there's a space for the pump to be installed, and we give the pump depth where it's installed for the pumping test. After that, we ask if a diver is going to be used for the test, and we will have our divers to you in May when we all meet in Tanzania, and you'll be able to take your diver with you to your pumping test, and that will be used in order to keep track and do a validation of the pumping test itself. Then from there, we want to have a picture of the pump itself with the specifications on the pump, because on the side of the pump, it will tell you what the power is, what the TDH it can do is, and also what the yield is. And then we ask, this is a very important question, we ask if the pump that's brought to the pumping test can fulfill the minimum requirement of the pumping. And that's 1.5 times whatever the driller's yield was. So that's super crucial because a lot of times we will get to the pumping test, and it's also something that needs to happen even before you arrive at the pumping test. The day before or 2 days before, you check with the pumping test contractor and you say, hey, do you have this pump? Is it ready? Have you tested it? Does it have such and such specifications? Then here on the form, you say yes or no. If we say no, we know that it's not enough and we will have to probably go back and redo the pumping test. Then you have the step test start date and the step test start time. We remember that our step tests take 4 hours, 1 hour for each step. And then we ask later on.
Duration.
then we ask later on the yield. 1 second, we'll get there. The duration of the recovery time to 95% of the standing water level. At the end of the pumping test, we want to see how long it will take for the water level to return to the static water level. Then we have the constant rate test start date and start time, and end date and end time, because sometimes the constant rate test will take longer. So we also ask here what the discharge rate for the constant rate is, and that's in liters per second. And we ask if there's an observation well used during the test. If there is an observation well used during a test, then we want to ask how far the observation well is from the borehole itself. And we ask for a GPS point. So we know where that observation well is. And observation wells are wells that could be a hand pump or a well that is not in service anymore. And that basically gives us more of an idea of what the extent of our aquifer is. When we are lucky enough to have them, it gives us a lot more information for the analysis, but they're not necessary. And then we ask during the constant rate test if a dynamic water level was reached. And that means if the graph of a dynamic rate, if the drawdown of the water level evened out over that time, or if it continued to go down and it did not stabilize.
If we select yes, then we get some more options.
If we say yes, we get the depth of the dynamic water level, where it stabilized and evened out. And then again, just like we had in the step test, we have the duration of recovery time to 95% of the standing water level. This recovery time is also very important. It gives us more information about the characteristics of the aquifer. And again, we have the supervisor recommends to proceed to the next stage. So the next step that we have is actually from the previous point. Due to programming limitations, we have to have the rates of the step test be at the end of this form itself. So just know that if you're wondering where the step test discharge rates are, they're at the bottom. We identify what the step is, and then we give a discharge rate. So remember, the rule of thumb is 1/3 of the driller's yield, 2/3 of the driller's yield, 3/3 of the driller's yield or the driller's yield, and then the 4/3 of the driller's yield. So that's what the basic rule of thumb is for these yields. And you want to calculate them ahead of time and make sure that the pumping test contractor knows what those are.
Right.
Okay, and then from here, we also ask for pictures. We can go to the,
Do we have any?
yeah, the pumps. So we can also have a setup, basically the setup of the pumping test. That's also always a nice picture. This can also be an excellent opportunity to take pictures. Oftentimes the community comes out and they're waiting. It's the first chance that they have to really get water. And so it can be a really great opportunity for pictures as well for the community. And here we have a couple of examples. We have the pump model and the pump specifications. These are two pumps that were used for a pumping test in Malawi. And you can see on the right side, we have the model number, which is SQ3. And then the Q, which is the yield or the rate, is 3 meters cubed per hour. The H is 70 meters. So that's how much it can pump 3 meters cubed per hour at a depth of 70 meters. So if it's less, it can pump more. If it's a shallower depth, it can pump more water.
Do you have any more for that? No.
I think
No.
no.
That's- Okay, disinfection.
Okay, so the first thing we do when we have finished a pumping test or we're at the end of the constant rate test, we're going to take a sample. That's a very important thing to remember as we're doing this. We're going to take a sample before we do disinfection. And the next stage for the forms that we're going to fill out is the disinfection. Actually, no, so we're going to fill out. Do you want to do sampling first and then disinfection? Hold on, we're going to go out. So this is also something that's a little bit different. We're going to do sampling, which comes at the end of the pumping test. And this is outside. So can you go back to the drop down?
Oh,
Okay, so this is for one specific borehole.
Should I go back?
No?
Or do-
Yeah, can you go back? Okay, so everything we were doing up until now was in the borehole supervision form. And now we are finishing the pumping test. We have to do water quality sampling. So we have to come out of that form itself and go to the water quality testing form. Start a new form, and then we have to choose the borehole that we worked on before. Here. Yeah. And then we go through the sample label, the sample type.
So in this case, it's just
Yeah, it's always going to only be raw water once you're in the in process, because we won't have it had any treatment yet. And then we have microbiological, physiochemical, or both. Project stage is post pumping, and the other 2 times that we can do it is after is if we have to go back or when we go back and we double check and make sure that the water is still clean right before we do hand over to the community. So here we're in post pump testing, pumping test, and we're going to pick the borehole type, which actually we won't know if it's main or backup. We will take that out next time. The borehole ID. And we have these 3 options. Remember that you have to do it on the borehole that you are currently working on. So you need to make sure to note which borehole it was in the borehole supervision form.
And these are the codes or the borehole IDs that were generated automatically by the Inno app, right? Not government borehole IDs.
We also have a separate space for the government IDs. So this is just for the Inno app. Then we have the yield of that borehole. And then we want to have the sample, what date the sample was taken on, what hour the sample was taken on, which laboratory it's going to, and the name of the laboratory representative who received the samples, the date it was submitted to the laboratory, and the hour it was submitted to the laboratory. So when the sample was taken versus when it arrived and when it was submitted to the laboratory, it should only be 6 hours, but sometimes it can take a little bit of time. But we need to know this information because sometimes if a sample comes back very bad and we don't really know why, we can always go back and check. Was it taken too late? Maybe the bacteria had a really long amount of time of chance to grow. There was an issue. So we need to know these pieces of information as well. And then we also have opportunities to do pictures. You can take a picture of the samples as you're taking the samples. We always love to see pictures of that and to show really good methods and procedures. And then also we want to have pictures of the samples themselves. So you have a record of what was submitted and making sure it's really nice to have a backup of like what you wrote on the label, because if the label comes back wonky from the laboratory, you want to make sure that what you submitted is what you submitted. And if there was a mistake, so then we'll go back and fix it. But it's nice to have an extra record there for us.
Okay, so now we're going to go back into the borehole.
Now we're going to go to borehole supervision. We're going to do disinfection. Okay, now in disinfection, we have the date of the borehole disinfection. Remember, it has to be after the sample was taken, the initial first sample. And then we have the purpose of the borehole disinfection, especially for the first disinfection, we do it on every borehole. It happens after the pumping test and after sampling. We ask whether or not the water quality sample is taken, just for a reminder for you. Give the name of the supervisor themselves, then the name of the contractor performing the disinfection. If we have a separate contractor doing it, if it's IA doing it also, and we ask, but we want to have contractors doing it. We also ask if full PPE was in use. This is to help us make sure that there was no reason to put anyone else in danger, because chlorine can be very dangerous. We want to measure the static water level and give the total depth of the borehole and the total water column in the borehole. So we have the static water level minus the total level, and we also have an explanation here, and that gives us the total water column. And from the total water column, then we can do the calculation for how much disinfectant we need for that amount of water. Remember, it's 200 ppm, 200 parts per million, chlorine to water. Then we ask what type of disinfectant agent was in use, if we used granules, tablets, or liquid. And then we also ask if you choose one of those things, it'll give you either the volume or the weight. So we use granules because it's usually the easiest. We ask for a picture of the label itself of whatever chlorine you are using, because if you have the label, then you can say like what percentage of chlorine is in that disinfectant, because sometimes it can vary from 50 to 75. And then it gives us the concentration of disinfectant in that disinfectant itself. Then it asks the weight of chlorine needed to make a 200 ppm solution.
We can show you if we selected liquid, then it would ask us for the volume, right, in liters, as opposed to granules or tablets, which is solid, so it's grams. So let's just stay with liquid. Okay.
Okay, and then so you mix everything up, you pour it into the borehole, you do the disinfection, and then you put in a pump and you pump out the water to make sure everything is mixing until there's a smell of chlorine that comes out. You can take out the pump, set the borehole, leave the borehole to rest for 24 hours while the disinfectant is in there to kill everything. And then you want to make sure, we can also have a picture of the high chlorine, high CL field test strip when you're doing the pumping. And then you leave the borehole to rest for 24 hours. You say yes or no. And then at the end of the 24 hours, you pump out all the water and you make sure that the chlorine is all out of the borehole. And you want to validate that by using a low chlorine test strip that we have. And we want to have a picture of that next to then we ask if the supervisor recommends to proceed the next stage. This is the time if you saw something weird, if the contractor didn't do anything correctly, if they didn't leave the chlorine for long enough because they were in a rush, or they didn't pump the chlorine out of the borehole and they just left the borehole. This is the time to give comments and say yes, no, and why. Because it's a really good way. So every time when we try to provide you with support, usually it's on WhatsApp, and then we have to go back and get all the history of every borehole, and it can take a lot of time. And we want to be able to provide you support as quickly as possible. And in order to do this, it's having better records and reports of what's going on. So this way we can help. And if there's an issue, we can go directly to a contractor and demand that they keep up with the IA standards.
Of course, if there are any concerns, if you have any concerns,
call us.
Yes, first contact us, let us know. But it's good to have it on record in these forms as well. That's what we do.
Yeah. And then from there we have pictures. So it's nice if you can take pictures of this situation. And then here we have a few examples. This isn't an exhaustive set of examples. These are just good examples that we found from our forms. And then here we have a picture of the disinfectant label. It's pretty small here, but you can see that it says 68% active chlorine on the left. And then we have two examples of using field test strips with pictures. The low range one is actually kind of, maybe I was taking the picture a little bit late, so it's faded out. But we would like to have pictures of these just to show that we were doing it in the field and making sure that the water was had high enough chlorine in order to kill everything, and B, at the end of the process, we had low enough chlorine that it wasn't a danger to anyone in the community. Then we're going to the last stage. A few days have passed by. We got the pumping test done with. We got the analysis back from the contractor, and now we get to go into post-pumping test analysis, which is the bread and butter of this project. We have to know what is happening with the pumping test to know how much yield we have for this borehole, how many people can we help, and get all of the information that we use in order to do the design. So at this point in time, we want to do the post-pumping test analysis. The contractor is supposed to be doing the analysis, but we right now are in a process of really scaling upwards and really increasing our standards. And so we need your help to do this post-pumping test analysis and help our contractors move through it to do the right way. So we have the name of the contractor representative who was doing the post-pumping test analysis, the name of the IA representative who was reviewing it. So it would be the hydrogeologist in many cases, sometimes a water engineer. And we want to know what the recommended yield is based on both the supervisor and what the contractor said. We want to take the contractor's analysis into account. We also want to do our own analysis. We've been doing trainings on this for the last few months, and we will continue to do trainings until it's easy and it's something that we don't have to think about. It will just become kind of part of what we're doing, so we can make sure that we're maximizing the amount of water from each borehole. We get the recommended yield from this analysis. We identify what the dynamic water level is, because we need that dynamic water level to give to the water engineers to get the TDH. And then we ask what the borehole, whether or not the borehole is viable, if it has a high enough yield of 1 liter per second, if the borehole construction was done correctly, and we make sure that the dynamic water level isn't underneath the screen casings, things like this. We say, yes, it's viable, we're moving on. No, it's not viable, we might need to redrill or pump at a lower rate, but we'll discuss it with headquarters. And then we have the recommended pump installation depth. This is also super important. We want to make sure it's installed in an area that has plain casing and not slotted casing, and that it's not too deep in the borehole that it will get buried in sediment. And then we have whether or not the supervisor recommends to proceed to construction. And that information goes directly on to our engineers, and we get to finish our part of the project and pass it on to the engineers for design and construction.
Just for clarification, the recommended pump installation depth, obviously this is the post-pumping analysis, right? So post-pumping test analysis. So this is the solar pump. This is the previous question in the post-pumping, in the pumping test, where we asked the recommended installation depth.
So those two things can be the same. They're often the same. But sometimes if we do the pumping test analysis and we see that the drawdown is too, if there's the water level gets too close to the pump and it's too dangerous, then we might need to change the depth of the pump and install it deeper if we can. So those two things very often are the same, but can be different. So it's important to decide which one it is, because the recommended pump installation depth is what we give to the engineers for how they're going to be doing their work from then on, so they can have the H.
So the last thing we can show you is just how to upload the water sample results. We go back to water quality testing.
Yeah, so after we get all of this stuff, we have all of the pumping tests done. We get our water quality results back. And this is going to be something wonderful for us moving forward as well, is we're starting to create a database of our water quality results, which will allow us to kind of identify trends in the areas that we have poor water quality. We can identify if there's an area that has a lot of fluoride, or if there's an area that is dealing with a lot of heavy metals or things like that. We can see that on the water quality results. So we want to do this by taking the water quality results form. We're opening it up. We give the date that the results were received, the date of the sample analysis. Again, this is an issue between when the laboratory gets the samples and when they actually do the analysis. And that can be a problem with microbiological, especially because it doesn't matter if we get the sample there in 6 hours. If they leave it for 3 days, the microbiological results will be bad. So
just again, sorry to clarify, this is the date that the sample results were received. And in the previous one, when we chose not water quality results, but water quality sampling, then we asked when were they received at the lab. So when did the lab receive them? But here we're talking about
the results,
the actual results. So when did we get them from the lab, which is also important information.
Then we have the laboratory reference number, which would come on the results themselves, and if it was approved by the laboratory for suitable for human consumption. After that, we have a few of the basic parameters just to make sure that the water quality analysis is good. It's not every parameter, it's not exhaustive, but I think it's about 10, 12, 12 different parameters. And then you just put in, we have given the units here. The units are based on what the other country, all of the countries give as the units, and you just fill in whatever it is in milligrams per liter. And then we want to ask here if there's other important minerals. If you have something else, we want you to ask you to enter units. Say if you have some sort of high aluminum or something like that. Again, we do it in milligrams per liter. And then here we also have a space to give comments. And we want you to take a picture and upload the file itself. So instead of having to go back into the drive and saving it in the drive and saving it also in the IA programs drive and also in the Malawi drive, and also send it on WhatsApp and also send it an email. We want to start having this all be unified and put into the database, so we have all the information in one spot.
All right.
And I think that's it. Do we have 34? Nervous.
Well done. Guys, I've been collecting all the questions as we've been going through, so I'm just going to start up at the top.
Yeah, Michal, I did collect if you want me to.
No, it's okay. I've got them.
You got them? Okay.
If we are redrilling an already existing project, do we start a new installation form or do we overwrite the existing data about the existing borehole?
It's not an installation form anymore. And we always start a new borehole supervision form for every new borehole.
Okay, fantastic. So if it's been redrilled, it's a new borehole form.
New borehole, yes.
Beautiful. And Mayan asked, are we not to move forward with a site that has less than 3 recommended points?
Listen, a lot of time, that's a difficult question because a lot of times, if there aren't 3 recommended, like it's a philosophical question. If there aren't 3 recommended points, maybe they didn't find 3 good points. We don't want to stop people from doing it, but we also really need to stop the situation where we'll find 3 recommended points and then they'll drill one borehole, the borehole comes back dry, and then suddenly they'll say that they need to do another survey and we have to pay for another survey. So the idea with the survey is that we want to make sure that they're taking time to do the survey correctly and to find 3 good prospective points. And from there, we will at least have the chance to drill 1, 2, or 3 boreholes that have a good chance of finding water, as opposed to drilling 1 borehole and going back to resurvey and drilling 1 borehole and going back to resurvey, because it takes a lot of time and a lot of money.
For sure. So I guess whilst they're doing the initial survey, they should also try and find at least 3 good points.
Exactly.
It has to be at least 3 good points, and we want to make sure that they're doing especially what they call a vertical VES, a vertical electrical sounding, that they're doing it at least 6 points, because we're finding out that sometimes a surveyor goes and they do 3 and then say, okay, it's time for coffee, we have to go. So we want to make sure that everybody is doing a full survey and getting as much information as possible.
Fantastic. So that leads to the next question then. We will need to include a clause about the 6 drilling points in the drilling contractor's contract.
Correct.
I know Tara does have a list of contracts, and that is in there. That will be reviewed at another time, but it will all be available to you on the drive. Can we add, this is from Sarah and then Mayan, can we add land consent form under the survey or drilling stages, Mayan suggested? So is land consent there, Tara, as part of the form?
It's not there, but I think it's actually a great idea. I just need to look and see, like, let's print one off and we can see about the points that need to be added in there. I don't know if the suggestion is to like replace the document altogether and just put it in the form, because then you won't have anything with the signature. So I don't know exactly what the idea was, but if
there is,
I mean, I guess maybe, I don't know. The question is if you're asking if we should ask if there's a land consent, or also use this opportunity
just to upload it.
To upload it, take a picture. Is that what
we
you're
can
asking, Sarah?
Yeah, I mean, that could be one of the documents. Again, it's the same thing that we talked about, like with an MOU. There's 2 options. If you have the document on your phone and it's easy for you to scan and upload it as a document from the app, that is now a capability that we can put in the phone, which is fantastic. Another option is if you already if you want to send it via email, those documents will be saved in the project docs hub on the database, and everybody will have access to that as well. So where it's uploaded, I think you guys can determine with your country directors and what's easiest for the team, but definitely the land consent form, the MOUs, any reporting or documentation will be connected to the project.
Great. And is there a place in the app that we should include the borehole registration number / status?
Yes.
I believe there is.
I think we had it on the
I
previous
think we have,
forms.
and
Maybe it did.
I got missed.
Yeah.
Actually, it's not there. I realized I looked into it.
It was definitely on one of the versions.
So one of the
So-
forms has the water quality has the borehole reference number, but we don't have a drilling reference number. Sorry.
I think
We
maybe,
have the sample reference number, but we don't have
No.
another borehole reference
but
number.
I think we talked about maybe not to have this conversation here, but I think we talked about maybe having the governmental borehole reference number only at the point where we move into viability. Because we
can put it on the installation form then.
Yeah. Or we could consider putting it back into the drilling form. It's just because once drilling is done and we still have so many steps before we decide to go with that specific borehole, then we don't want to add a spot where you have to go back into the form and edit it. It'll be part of like the form when you're going forward. Yes, this borehole is viable. We're moving forward with it. 100% we're making a project. And then you ask for what the government borehole references.
You tell me where you want it and we'll put it in.
I think it's also a good question for the hydrogeologist, because I know also in South Africa, you guys like to have, also they do register dry boreholes in South Africa. So we will talk about it.
Okay, excellent. Question from Tanzania. In a sanitary seal, what are the recommendations? Bentonite pellets or bentonite powder? Availability of bentonite pellets in Tanzania is also a challenge. Similarly, in Uganda and Malawi, they have brought that up as well.
Fair. So we understand that we would like to be moving more towards having pellets for everyone, just because it's so much easier to install, and there's no question of what the ratio is to water or to water and bentonite powder. You basically install it as if it's gravel pack, and it is dense enough that it just sinks to the bottom of the borehole and it gets installed where you choose to install it, versus bentonite that you mix together by yourself. It can kind of get stuck on the sides of the borehole, and we don't know really exactly where it is. So we would like to be moving towards pellets, and hopefully this year, if we can figure out if we're doing all of these shipments, maybe for construction, we could add bentonite pellets on and make sure that every country gets their own, or we do special shipments of a lot as IA, and we can sell it to the contractors separately. So we will do our very, very best to make sure that we're getting this material to you, because it's much easier and more effective to use.
Excellent. So instead, you're suggesting that what should they do if
we
not?
would much prefer bentonite pellets. We will try to help as much as we can to facilitate getting those pellets to the contractors, even if it's just us. In the meantime, as things go on, we want to make sure that the sanitary seal is happening. So powder is fine for now, but this year I would like to make the full transition into pellets for everyone.
Sure, thank you. And just on that, Uganda, they have disinfectant in powder form. Can they include the powder in the app, or does it only have options for the other form?
Powder and granules, same.
Yeah.
Okay, terrific. Just to clarify that point, is it advisable to hire a separate contractor to do the pump test instead of using the same contractor for both drilling and the pump test?
It depends on how reliable the contractor is, but that's also the reason why we're there to be doing the supervision. We can have a separate contractor. I understand that maybe the question here is about whether or not there's a conflict of interest. If the drilling contractor says there's 1 liter per second and he's also the pumping test contractor, and he says, oh, so it's also 1 liter per second, but it might not be. That's why we would like to go in and make sure we're doing the supervision and making sure that everything is going on correctly. So it depends on how reliable your contractor is. If your contractor is really not reliable, then maybe we should consider it. But we'd really like to keep everything as condensed as possible.
Absolutely. Okay. Last 2 questions. For boreholes which were already drilled and we are waiting for, let's say, the pumping test, the sampling and disinfection, is it possible to fill the forms in for the remaining borehole stages, or do we have to work backwards?
Start once again. The first part.
Yeah, for boreholes which were already drilled and are waiting for the pumping test, sampling and disinfection, is it possible to fill in the forms for the remaining borehole stages, or do we have to work backwards?
Is the question of
technical
an
question?
existing
No, it's about the forms.
one borehole in multiple stages,
always-
or are we talking about two different boreholes,
Let's see.
happening simultaneously?
Go back to the chat and see who asked that, and maybe they can.
It's Rogers.
Rogers, do you want to clarify your question for us, Rogers?
Yeah, thank you. No, we can see that we have forms right from surveying stage and all that, but we already drilled some boreholes in preparation for 2022, and so I was just inquiring. We already missed out some stages, so these boreholes we need to do test pumping now, disinfection, etc. Do we need to start from the stages which are left, like the test pumping, the disinfection, or we need to first fill the
Yeah,
forms?
I don't think so. But it is important to make sure that all of the field forms that you still have are uploaded onto either the database or in the drive. But I think that we should talk about doing this from the first drill that you guys do this year moving forward.
Fantastic. And the very last question, what do I do with the information that's completed on different days? Do I submit it per day or save and wait to submit it once it's all done?
Ooh, this is a question for Tara. Can they go back and edit a form if it's on multiple days?
Yeah, they definitely can. I would recommend that
So submit.
Yeah, I would
Submit
recommend
and then
that
go back
you
and add.
submit any data that you have, and then you can always go back in and edit an existing form. So say you only, like pumping test takes a couple of days and you want to, put all the information you can from day one, submit it. You can always go back in and edit, day two.
Yeah. So
Do
for
they-
example, if you're filling out the step tests, right, and then the constant rate test would be the next day or whatever, then at least if when you submit it, we'll be able to get that information in the meantime, as opposed to if you just save it, then it will be saved in the app in your user, but we won't be able to see it. So the quicker it can get to us, the better.
Fantastic. So I guess the advice here is to complete it there and then, submit it as soon as possible. Then you can always go back in to edit, add more information, or complete the next stages as you go. And I think all those questions have been answered. Thank you, everyone.
I have a question.
Later, Shai.
Shy.
Oh, okay, bye. Okay, maybe it's more question for Tara and maybe just for all of us to think about how we are going to transition from the borehole supervision form to actually doing the design. So how the data is going to be transferred from one department to another.
It's a good question. I think that what we can set up is that, for instance, if you headquarters and water engineering department need to have the post pumping test analysis form come to you so that you can begin the EPINET part, then we can arrange for just that stage to come to you. You don't necessarily have to get all the stages of the drilling and surveying and all of that.
Yeah, absolutely not. But just like for us to know that it was approved by Emily and that we can move forward with doing the design.
I think that that's going to be part of the system we create in the processes we create on this side through the web database, and not necessarily through the forms.
All right.
Cool. Thank you guys for listening. That was long. Hopefully it will be more straightforward than the installation form that just went on forever. But